Hi guys, Craig here and welcome back to the channel. Today I'm going to be testing the new SafeBatt Lite. So this is a 300 amp hour lithium ferrophosphate battery. And you did see my short that I did. I went up to the guys at SafeBatt, saw the operation up there, and they are hand assembling these batteries. So really good to see that happening in Australia. The other thing that I have found, and you can see it here on the right hand side that nobody's talking about yet, is there is Bluetooth on this battery. They're using it to set the internal parameters of the battery, and they can go in and keep an eye on things, but they're not making it publicly known. But I'm going to out them right now and say there is an app that works for this. And I checked a couple online just at the App Store, and I found one called Fusion BMS and downloaded that. And yeah, so it works fine. So it gives me cell information, gives me data, health, cycles, temperature, everything you really want to know on a battery. So I think that's really handy. So I'm going to use this while I'm testing this battery. So as you can see right now, we've got a 7 millivolt deviation. The battery's coming up to full absorption at 14.2 volts. So I'm just letting it do its thing here now. So you can still see it is taking charge, but not much charge. It's taking 188 watts. So we'll let that complete its absorption cycle, and then I'm going to do a discharge test on it. Really excited by this battery. So let's see how it goes. So just looking at the specs, so 300 amp hour, LFP 12.8, 3.84 kilowatt hours. They're telling me it's a prismatic battery with 4S1P, so it's 4 individual cells in here. Float and storage 14.2, 13.5, that all looks normal. 200 amp charge and 200 amp discharge rate, and standard temperatures here. Oh, compliance with ISC 62619, that's very good. Okay, so let's charge this thing up, let it finish off, and then I'll come back to you and do a discharge. Just while the battery's finishing off the absorption charge, I just thought I'd do a size comparison and have a look at that. So that's 300 amp hours, and that's 200 amp hours. It's about the same height, but the rest of it, look, it's probably, yes, it's probably a little bit wider, but it's compact, hey? That's a really compact battery for the footprint at 300 amp hours. Okay, so the battery's now fully charged, sitting at 14.2 volts, and you'll see that if I look at the parameters in this Fusion BMS app, we're 0.4 millivolt deviation, and everything's balanced really nice there. So it's stopped taking charge, so now I'll discharge it. So let's just put a load on it here. I've reset the shunt, recalibrated back to 300 amp hours, so everything's matched. I'm now using this little battery charger here to charge this battery bank from the 300 amp hour battery. So the advantage of that is it's a constant load, and when I'm load dumping, I'm not letting it go to waste. So I'm actually now topping up my other battery bank. So we just have a quick look here. So we're discharging now at 155 amps, and we'll see how long that takes. So 155 amps at around 1800 watts. And as I said, this has a maximum discharge rate of 200 amps. So we're up there. You know, we're not quite at the 200, but 157.3. So we'll keep an eye on that, and we'll come back. Okay, continuing back now, we're down to 85% on the BMS data here from this app that I found online, which was called Fusion BMS, for those guys that want to use it. I've just done a quick temperature check as well, and I'll show you. 28 degrees on the 26, 24, 28, thereabouts. 29, 30 degrees on the positive, all well within limits. 85% down here, and you come over to here and we're saying 83%, a couple of percent deviation. That doesn't worry me at all. We've got down to 12.4 volts here, And over this side, what have we got? 12.8 volts it's showing. So everything looks great. Cell voltages look good. We've got a 11 millivolt deviation on the cells, highest to lowest, so no problems with that. Again, nothing concerning me here. We'll let this test run. It's settled in at, call it 163 amps. We'll come back a bit later on and see how this is going. I mean, terminals are warm. You can still touch them, so I'm not too fussed about that. 168 amps. Down to 30% now. AC output 1800 watts, 230 volts. Yeah, so it's about 8 amps at the 230 volt range. And going across here, again, this is that battery charger, 1611 watts, going into my house system here. So we've reached the 200 amp hours now, and the state of charge is saying 28%, so that's probably a little bit less. If you base 28% on 300 amp hours, that math there tells you that it's not going to make 300 amp hours, but let's see how it goes. Battery voltage has come down a little bit now. It's saying 12.27 here, but it's still holding nicely here at 12.7. Deviation's about the same as what it was before. So we'll just keep watching this and see where we get to. But it is, like, footprint wise, it's sensational. You know, if I grab this battery here, for example, which we all know and love, so that's 200 amp hours, 300 amp hours. Yeah, it's a little bit bigger, but you know, it's nothing compared to the size of those batteries down there on the floor. So I thought I'd just throw a multimeter across the terminals here, and you can see we're getting 12.49 volts here, 12.7 volts. I mean, it's only one decimal place, so it's probably rounding up, but 12.7 volts according to the app. And then at the shunt, we're getting 12.23 volts, 12.24. So again, I'm going to base, and I've said this multiple times in my videos, I like a battery to achieve its output down to 12 volt. So we'll keep an eye on these, and we'll take a bit of an average, and we'll see what we can get out of this battery down to 12 volt. Also, the guys at SafeBatt have told me that they don't let this battery wring its neck and go down to 2.5 volts per cell like most other manufacturers do. It should cut out around 11.6 volts and still make its 300 amp hours. So I guess we'll see that in the next half an hour or so and see what happens there. But it's just interesting. You know, I've got 95mm cable here running, and that'd be, you know, a good 1.2 meters long, something like that, maybe a bit more, 4 or 5 foot long. And you can see the voltage drop, which is quite normal. I mean, I throw any battery, you know, on the end of these terminals, and they're all going to do exactly the same thing, so that doesn't concern me at all. 49 millivolt deviation, chops and changes a little bit, let's call it 50, but everything's looking good there. You know, these terminals, sure, they're warm, but they're not hot to touch. Like, I've had terminals here that you'd never put your hand on. What's that, 33, 34 degrees, 34 degrees, 29, 30 on that one, on the negative. So yeah, it's quite nice. We're at 290 amp hours, and the battery's saying 11.1, but that's at the shunt, not at the battery. So I reckon I'm going to go What am I going to pick? Do I pick this one, 12.17? Do I pick the 12.3? Somewhere around there, I want this battery to achieve, when this drops to 12 volt, 300 amp hours, and I'll be a happy man. What have we got now? 292 amp hours. You can see the load still holding nicely. Amps have come up slightly, falling at 174 amps now, which is quite normal. Voltage drops, amps come up. We say it all the time, but we all know it. 293. It's all looking good. Okay, we're getting towards the pointy end now. We're getting close to our 300 amp hours. 299.3, 12.03 volts at the terminals, 12.2 volts at the BMS, and at the shunt 11.75. So let's just, there we go, 300 amp hours, guys. 12.01, 12.2. So this is made, it's 300 amp hours at 12 volts. There we go. It's just dropped to 11.99, 300.6. So if we just make a note of that, 300 amp hours at, what did I say it was? It was 12.02, I think. So the data will show it. Now we'll let it run until it cuts out and see what we get to. So I think we'll stay with it all the way to the end now, guys. So it's cell number 1 that's going to let go first. So my understanding, the parameters on this battery, it's going to cut at 11.6 volt pack, and individual cell voltage I'm not sure, so we'll see what it is. 303.7 amp hours now, you can clearly see that. 304 amp hours. As I said, I'm a big fan of always its rated capacity down to 12 volts, which this battery just did, there or thereabouts. I think we're splitting hairs arguing the difference. Let's let it keep going. 11.77. And there we go, guys. Under cell voltage protection just popped up on the thing. And let's see what we get to. Okay, so the voltage has come off, so it's gone into protection mode, which is exactly what it's supposed to do. It's made its 300 amp hours. So honestly, guys, that tells me what's going to happen. You're going to get a lot of life cycles out of this battery because you're not wringing its neck down to 10 volts. Okay, another little alarm just popped up, which is quite interesting. I've never really used this app before, so you're seeing it as I'm seeing it. Now we might have to put a bit of charge up its arse for it to come back on. I'll plug some solar in, that might be enough. It's only one panel I've got on there, but let's see what happens. But it made around, I think, 305 amp hours before the cell voltage cut out, and the servo's now come back on with that little bit of solar, so that's enough to make it cut back in. 78 millivolt deviation, quite normal. I was surprised it doesn't go over 100 millivolt, to be honest with you. Okay, so we got our 300 amp hours. I'm going to now charge it back up. Then I'll do another discharge test on it and make sure we can repeat the results. And I'll come back to you shortly. So I've just put some charge back into this battery. I'm going to bring it back up and charge it up to 12.2 volts again. But interesting, so I've got, 1900 watts of load going into it, which is 118 amp. Okay, so it's bulking back up now. Let's go in here. You can see it's come back up to 5%, etc. But the interesting point that I wanted to show you was straight away the cell deviation is now down to 7 millivolts, and the battery has only been on charge for a couple of minutes. So that deviation there that we had before has just about all but disappeared. I find that interesting. I don't know if it's unique or not, but it's definitely interesting. So yeah. Yeah, so just confirming the BMS undervoltage protection. So it's 11.6 volts or 2.9 volts per cell will trigger the undervoltage protection. So that's what we saw here when it made 305.3 amp hours. It was the cell voltage that dropped to 2.9 volts, which is still fantastic. And the fact that it made 300 amp hours at 12 volts is, I'm really, really happy with that. I've now charged the battery back up, and I just thought I'd show you the deviations on the cells now. So it's sitting at 31 millivolts deviation, which, in my book is quite acceptable, but it's still taking a little bit of charge. So it's still taking a little bit of charge. It's only like 40 watts that's going into this battery. Now that would tell me that it's balancing. So the great thing with this battery is it hasn't gone into cell overvoltage protection, so it allows for the cells now to continue to balance by taking charge. So what normally happens with the passive balancer is that cell overvoltage protection would trip, or pack overvoltage protection would trip, and then the balancing feature would stop working. But with this battery, because it hasn't tripped and it's still charging, you can see that by the charging switches both on and discharges on, that it's still taking charge, and therefore I would expect this cell deviation to drop. Now, looking at the specs here, I believe that it goes down to a balancing of 10 millivolts per cell. So once it hits 10 or under, then it will stop the balancing function of this battery. So I'll come back a bit later on. I'm not sure how long this is going to take, but I'm just going to let it do its thing, and we'll see where we get to. So about an hour's passed now. The voltage has dropped off a little bit. I think say it's finished its absorption charge, but the cell deviation now has come down to 19 millivolts. And as you can see there, I mean, it's perfectly behaved. I don't really know that I need to watch this anymore. Oh, there we go. 18, 19, it's toggling. So it's still coming down. Yep, definitely still coming down there, sitting and holding at 18 now. So yeah, I would think this is just going to keep coming down till these cells get perfectly balanced. So there you go, guys. There's a nice introduction to the new SafeBatt Lite 300 amp hour battery. So far, first discharge test, it behaved faultlessly. I mean, 300 amp hours down to 12 volt, and it cut out at 305 amp hours at 2.9 volts per cell, or 11.6 volts. So really, really happy so far. I guess the next thing to do, like I said, I'll probably do another discharge test at a lesser discharge than 170 amps. I think I'll drop it down to say 100 amps, which might be a little bit more realistic for a real world test. And I say it all the time, but nobody's going to cycle these batteries continuously, at a discharge rate of 168 amps until the battery drops dead. It's just not going to be a reality. But I do it because it says in the specs that it can be done. So that's the reason I hit them with a pretty hard discharge current. Okay, so it's the next morning, back with the SafeBatt Lite, and what I'm going to do is do another discharge test on this battery. It's all charged back up. I've reset the shunt, sitting at 14.2 volts, 100%. So the load you see on it there, that's the consumption of the unit, and the PV charger I've still got plugged in. So what I'm going to do now is I'm going to put a smaller load on this battery. I've of around 800 to 1000 watts this time, and just see what sort of capacity we get out of it. Look, it's gonna do these numbers again at the very least, and may even do a bit more than that. It won't be much. My guess will be a couple of amp hours would be all you'll get by decreasing the load on the unit. So let's unplug the solar. Okay, shunts reset to 0. Back to the fan heater. Let's put a load on that, let it come up, and then we'll let it settle in. So 850 watts thereabouts. It's bouncing around a little bit. It will settle. So we'll do a discharge test on that. As you can see, cell voltages all look good. Low deviation there, 7 millivolts. All the cells are holding nicely over 3.4 volts. Yeah, sure, that's going to come down very quickly now, but this will take a few hours to do this test. So I'll check it throughout the morning and come back to you. Quite a bit of time has passed now, and still going with this discharge test. We've got state of charge 22% remaining, amp hours consumed 233.6, and the voltage is still quite high, 12.66. So you can see under a heavier load the voltage drop is more, again quite normal. Cell deviation 6 millivolts. All the cells are still over 3.2 volts per cell. Like, it's just pretty boring, but boring is nice. It means we've got no issues. 23 degrees. Oops, the glare again. 24 degrees. Yep. No issues at all. So we've got an hour to go. So we'll let that run. I'll come back and catch it at the end. Coming right down now, 12.4 volts. All the cells are still over 3 volts per cell, the lowest being number 1 again, with a 25 millivolt deviation. Yeah, doesn't worry me too much. Terminals are cold, and we've produced 297 amp hours so far. So we're just about there, guys. Won't hold the video now. I'll come back to it again, because I think we've still got a little way to go before we get down to our 12 volts, where I want to record the number, and let's see what amp hours we get this time around. So getting real close now to 300 amp hours, so we'll get that. Let's hold it on it. So there you go, 300 amp hours down to 12.28, 12.3 there, 12.18 there, 300, .28 volt. So you got to say that's a lot better than yesterday, when we were at 12.02 volt to 12.28 volt. So yeah, looks like I'm going to bite my tongue here and have to go back on my words, because I thought these figures would be very close. I thought only 1 or 2 amp hours in it before it gets down to it. It looks like it's going to achieve more than that this time around. So yeah, we'll keep going. So yesterday at that 12.02, I used this multimeter as the reference. So to be fair, we'll use that as a reference again today. When that hits 12 volt or 12.02 volts thereabouts, we'll check the capacity. Deviation's starting to rise now, which again, completely normal. I don't have a problem with that. So you can see the load still consistent the whole way through, no issues. just thought I'd show you. We've just clicked 12 volt at the shunt. 12 volt at the shunt, and we got 303.8. So I'm gonna make a note of that as well. 303.8 at 12.00 at the shunt. Okay. And we're just about now come down. Oops. That was smart, wasn't it, Craig? 12.05. And when it gets to 12.02, I'm going to grab that number. There we go. 304.8. 304.8 at 12.02 volt, which is the same as what we got here yesterday. So we got 4.8 amp hours more today, which I'm very surprised by, but happy to eat my words. So this should cut out at 2.90, so I'll keep an eye on that. In fact, if I move that to there, and we should get the numbers and see what we can get for you. .95, it's holding on. And 306.2 amp hours. I mean, this is obviously a pass, and it's an easy pass for this battery. It's done it, you know, flawlessly. Okay, 2.932. Now this may be a little bit out. I don't know how accurate this app is. Just keep watching it. 307.3. Cells now at 2.915. So it should cut out at 2.9 volts there or thereabouts. It's going to have a slight delay on it. 307.7 amp hours. Again, I've never seen this where a battery will hold this voltage and overproduce by so much. There we go, 308.1. 308.1. 308.1 amp hours. Solid result. And I bet you, I'll just turn the inverter off now, take the load off it. I nearly guarantee you that I could get more out of this battery. Remember I did the little light bulb trick on them before, trying to wring their necks and get every last bit out of it. And you shouldn't have to do that, you know, when the cell protection cuts in, which it clearly did. This cell got down to the BMS cutoff limit and, yeah, cut it off. So I think that's good enough, guys. Like, I'm really happy with 308.1, and especially, you know, whether you take this or this number here, it's, you know, you're splitting hairs. But somewhere between, you know, let's call it round of 304 amp hours down to 12 volt. So it achieved another, you know, 4 amp hours over the top of this, and another, and 3 amp hours, or a bit less than 3 amp hours, from 308 to 305. So I was pretty close. I thought it, you know, was going to be within a couple of amp hours, and yeah, I guess I was being a bit hard on myself. That's close enough. Which also then proves to me, you know, and I've seen it in other batteries, whether you discharge it at 168 amps at a very high load or a moderate load of 60 amps, you generally only get a few amp hours difference. Yeah, they all seem to do that. So yeah, the voltage now has come back up to 12.1, but the protection hasn't cut off because I don't know what it is. It could be at, you know, a cell voltage of, you know, 3.1 or 3.2 volts before it allows the BMS to cut back in. I can confirm those numbers for you if anybody's interested. Like I said, I could reduce the cell voltage down to 2.5 volts per cell and 10 volts overall as a pack, and push this battery a bit harder. But you know what, quite honestly, I don't think I'm going to bother. I'm happy with the results of it. You know, and if you take 12.8 times, it made 308, oops, 12.8 times 308.1, what do we get? 3.943 kilowatt hours, so just under 4 kilowatt hours, or 4,000 watt hours. So, you know, it makes nameplate and then some. Okay, so the lid's off, and first impression is, wow, this is a very, very tidy battery. 4 prismatic cells, flexible bus bars. You can see they've put their mark on the tops of the bolts after they've torqued them down. Everything's nice and tight. We've got twin 25mm squared cable, and they're equal length, which is always a good thing. Twin 25s here as well. BMS is down the side here, and I don't know whether you can see it in the video, but it's in a metal girdle, and then there's a plate, and then there's another plate at this end, and the batteries are held together. So they're taped together and then secured inside this battery pack. So not a lot of room at all, which is what makes it a very compact footprint. Interesting is the air gap that they've got here, so to allow the BMS to cool or dissipate some of the heat when it's running hard, which is why it didn't get hot on the casing, which is great. A lot of them I see that sometimes they're hard up against the case or mounted over the top of the cells here, and there's just no room. So I really like this idea, and I think it provides that little bit more protection for the BMS. Okay, so I've connected the battery up, taped up the terminals, so I'm trying to be as safe as I possibly can. I'll do a hard discharge on it now, and check the amps across here, and I'll check some temperatures. I'll make sure that you know, the QA process has been followed through, and this battery has no issues. But from what I can see here, it's all looking fantastic. I've got to admit, this is one of the best looking batteries that I've ever opened. And I'd say, look, it is hand built here in Australia, so in Wollongong in New South Wales. So yeah, fantastic so far. Well, I think I'm going to end the video there, guys. There's not much else I can really do. It's done everything that this battery was meant to do. It's passed all my tests. It looks fantastic with the lid off. Yeah, like, beautiful design battery, works great, footprint's perfect. It is a premium battery, as I said. It's around the $2,700 mark. I believe I'll be going to be given a discount code. So if you want to jump online and buy one of these batteries from the boys at SafeBatt, then I'll pin that discount code in the comments, and you can go from there. But look, it really has performed well. It presents well. It's really well built. I can't really fault it. All right. Thanks. definitely a pass from me. Stay tuned for the next one.